So, welcome back now to our next session, just before the coffee break. This time with Clément, talking about extending an API via Steampunk, just to make it a little bit shorter. So you see, shorter title, speaker. And also, I'm very happy to have him here. He is also an avid blogger. He has his own blog, ABAP, and if I'm not really good at French, but I think it means like an ABAP developer person. Yeah, the I think is for the person part. Oh. Welcome him. He will talking about a very normal, I think, use case. You normally get this kind of use case from the CAP side, extending in a SAP API, and he's doing it also now with the ABAP environment on Steampunk. So the stage is yours, Clément. Have fun.
Thank you. Hello, everyone. So thank you, Tobias, for the introduction. I'm not sure why you talked about my French accent. It's pretty transparent. No. So yeah, today we will talk about API and BTP ABAP Environment. For this, we will build together a use case. This use case will be to create a Fiori application. It will allow to how business users to create orders which are linked to external products. These products we will consume a remote API, the Northwind API. I think some of you know this public API, and we will consume the product entity. After this, we will show the product on the Fiori application, and we will also extend this API to allow the business users to add some comments, and after this, to add some orders linked to this external product. If we take a little look to the Northwind API, this is so a public API. We can access it through the web browser, and we can see there is a further entity on what we will use here for our demo. It's the product entity. Same, if you navigate to the product entity, you will see all the data that is stored about the product available in the Northwind API. So we will call this API and we will display the data on a Fiori application. To be more concrete, if we have from the beginning a look at the result at the end of what we will build together, the application will look like this. So we will call the So here, this is the data available in the public API, the remote API, and we are displaying it, and what we will add is the possibility to add a comment. This comment will be persisted in our own database. Here, for example, I can create my own comment on this product, which is not stored in my BTP ABAP environment, but in the remote API, but the comment is stored on my system. I can also create an order which is linked to this external product. So we will go step by step to see how we can create this together. So what I was saying is first we will take an external system. Here it's the Northwind system, but it can also be your ECC system, your S4 system. You just need a remote API, and we will build a remote client proxy. This remote client proxy will allow you to consume easily the external system, and then on top of this, we will create a CDS custom entity, which will call the remote client proxy to get the data from the remote API. After this, we will create the database information to persist our own data that we will add. And we will create on top of this all the elements needed for the Fiori application that we will create. So we will create a wrap object, and this wrap object will exchange with the remote API. So here the Northwind API is just giving us the read possibility, but imagine that you could also update the description of the product or something like this, delete some products. It will be also possible to add this possibility in the wrap object. But just for now, we will read the information of the product and add our own data on the BTP ABAP environment. So we will have 4 steps. First, the proxy creation, the consumption and the presentation in a Fiori app, and we will add first the comment and then the composition to an order entity. First step, so the proxy creation with the service consumption model. The objective is to consume the product service of the Northwind API. For this, we will create the proxy. We will use a service available in the BTP ABAP environment, the service consumption model. And with this, we will call the API. It's really easy and standardized way to call API. So maybe I will zoom. The first step here. New repository object. Service consumption model. You give a name, so here, for example, service consumption for ABAPConf. It's a no data service. And what asks the system is the service metadata file. So we can find the metadata here. Normally it's like something like this. Metadata. So you just have to download the metadata and put it on the system. What the system do, it's automatically it will see all the entity available, and it will create a class to work with these entities on this API. So we are waiting for the generation. Once it's done, the service consumption model is created, and you have here on the right some example that explain you how to call the service consumption model with a client proxy. So for example, here we want to call the product entity a read statement, and you just have to copy paste this code and to put the HTTP information to call the API, and it will give you the answer from the API call. So the first test we can do is copy paste this scenario. I have already done this. And here, for example, we have created together the service consumption model. I will change the ID. Here you put the ID of the proxy. Okay. And then at the end, what I'm doing is just I display the product ID on the description of the products. And here what I do is I request precisely the product with the ID 1. So if I press F9 on the console, we can see that the product ID is 1 and its description is child. So if I go back to the API, that's what it is stored in the Northwind API. If we go more in details, on debug, here, first we create the destination. So the destination is the URL of the service. Here the service is the Northwind service. Then we create the HTTP destination. And then we create the remote proxy for this destination. And what we give here is the path to call the good entity. So what we give later to the remote is the key that we want to call. Here the product ID 1. And then when we execute the get request in this variable, what we can have is the answer of the API. So with the service consumption model, we have not to create manually all the objects. Everything is created automatically. The structure is created also automatically. I just have to call the API and all the data will be stored automatically here. That's the first part. Oops. Then, on top of this consumption model on remote proxy, we want to create a wrap object. So we will need a CDS entity. And this CDS entity will be used to display the products available on the Northwind API on a Fiori application. So the objective is simple, it's to display the products. And for this, we will create the entity, the CDS entity, and this CDS entity will call the API on the fly when we will call it. I think it will be more clear like this. So we have all your external system. It will be called by the remote client proxy. The data that will be retrieved by this proxy will be stored in the custom entity. And we will create the service binding on top of this custom entity to display the data on the Fiori application. The first things to do, so it's to create the CDS object. As we are finding all the data outside of our system, we have to create a CDS custom entity. And the structure of the custom entity is really simple. It's just the same structure of the API. So if you look to the API, we have the product ID, the product name, the supplier ID, the category ID, etc. And that's the same, exactly the same on the CDS custom entity. What we have to do is to implement a class that will be query the external API, the remote API, and this is done in this class. So if we navigate to this class, what we can see is that first, as it's a query for a wrap application, we have to implement this interface. And in this interface, we have one method that is the select method. On this select method, we will again call the remote proxy that we have created. And with this remote proxy, we will have all the data needed to be displayed in the Fiori application. Just to show you the result, and then we will dive in more details on this application. So here, this is the first part. Oh. We only have the information that is on the remote API, nothing more. If I click on this, I have nothing. This is just the custom CDS entity that gets the data and it's displayed in the Fiori application. So now, if we go in debug to see more precisely what's done. So again, we are calling the client proxy, but here we are not filtering in the product ID.
Ah.
Select into our database the data that is stored from this product we will call, and it will be displayed in the Fiori application. What's that?
Strategy. Hopefully now it works.
Okay. So here, when we call the modified Fiori application, now we will have the comment that is added here, but we still have to implement the behavior logic to be able to persist the data in our database. So that's what we'll do, creating the wrap object. So on top of this root custom entity, we have to create the behavior definition. As you can see, as it's a custom CDS entity with unmanaged query, we do not have the choice. The implementation type of this wrap object should be unmanaged. So as I'm a very good developer, everything is ready. Here. So what we do in this behavior definition, it is really simple. We just allow the user to do update, and the update is only allowed on the command field because we do not have the possibility on our side to change all the other fields. They are stored outside of our system on the remote API. So every other fields than the command field are on read-only. So we can navigate to the class, the implementation class of the behavior. What we can see is we have created the buffers that I was talking just before to store the data that we want to modify. And we implement manually the update method. So we will loop on the entities that we want to change, and we will store the comment that has been given by the user and put it on the buffer. Then, when all validations are good and all data is determined, the wrap framework will automatically call the save sequence, and we will go in the save method, and then we will persist the data in the table we have created just before. So, for the example here, I will add a comment. Okay. We will save. So here we are on the first step. The wrap framework will call the update method, which is on the interaction phase. And this is the command that the business user have sent to the wrap object, and it will be stored in the buffer variable. Then, after this, when everything is good and validated, the wrap framework will call the save method automatically, and what we will do is just loop at the buffer where the data is stored, and we will persist the table. Like this. When I go back to the UI now, this is saved. I can find here my comment, and then when I go back to the table, here I will do a refresh. Now the comment is stored. So every time I will call the get method of my wrap object, it will call the API of Northwind, and it will find the comment I have linked to this API, and it will display on my screen. Now we want to add a little more complexity. We want to give the opportunity to the user to create some orders linked to these products. So for this, we need to create a new entity. This is an entity that is created on our BTP system. The data is also stored in our BTP system. And the thing we have to do is create a composition between the product entity and the order entity. At the end, this is the final schema. We will have the root custom entity, which represents the products, and all the orders. We can have many orders linked to one product. We will create a composition link between these two entities and store the orders on our own database. So that's the table we have to create to store the new orders that we will create. So we link again the orders to the product with the key product ID, and we will also create an order ID for the new orders that will be created. We add the possibility for the customer to add the quantity they want to order. And we will modify one last time our first CDS. Core data services. And what we do here is we create the composition to the order entity that we will create. So if we go to our order entity, this is the entity that is created. We are just selecting the data from the table we just created, the order table. And we are taking the product ID, order ID, and the quantity, and we do the link to the product. So this is a two-parent association because we have one product for multiple orders. In our case here for the test. In the behavior definition, some things have changed. We have now still the update of the comment on the other fields in read-only, but we have also the association to the orders that the user will create, and we have the creation of the new behavior definition for the orders entity. For the order entity, we want to give the opportunity to the user to update the order, delete the order, or create here by association the order. On the implementation part, what we can see is we have also add some buffer to manage the order creation, the order deletion, the order update, and the things that it's particular here is that I have asked for late numbering. So like this, the ID of the order is creating only on the save phase. So when we activate the late numbering, a method is created which is adjust number here. On the adjust number, I will give the order ID number that I want to the order that is created. At the end, the result is here. Okay, so I will still have my command field here, but the important here is for the link to the order. And what we can do now is create some order. So what we can see is the order ID, it's still not created. It will be created only on the save phase. I'm just giving some quantity of the product ordered, and it will be saved automatically. If we go in details one last time in the code, for example, for the create by association here. Oh. Okay. For example, if I take this, I will create a new one. We can, for the last inspection, try to see what's happening in the Fiori application. So we will create with the quantity. We will create a new order. So what we can see here, it's on the payload that a post for creation is done. And this is created by creation by association that we want. We can see here the link to the association, the two-order association, and what is sent is the information, the product ID, with the quantity that we want to create. So we loop at the entities that are sent by the UI. We have the information that we want, the product ID, and here, the quantity that is asked by the user. What is important here, we can see that we are not yet creating the order ID. So we are giving to the wrap framework a preliminary ID that will be then replaced by the real key of the entity. Here, on the adjust number, so we are on the save phase, we have to now create the order ID number. Okay, here. What we do is we loop on all the created orders, and we can see that there is no order ID created. So what our job is here, it's to create the order ID, yes, and to put it on the mapped structure just to let the wrap framework know that we have created the order ID. And at the end, here, the order ID is also persisted in our database. So if I go to the database I have created for the orders, here, and I display the, not this one, Okay, I think I have some network issue, but the data will be persisted in the database we have created, and the user can now store in his own data that is linked to the remote API. So thank you for your attention. The demo is complete. If you want to see in more detail the code that I have created for the ABAP conference, it's available in the GitLab, so you can take a look. If you have some questions, you can contact me on LinkedIn. I will answer to you. And if you want to follow us to have some new information on our blogs, you can also take a look to the blog ABAPer, where I put some new article, one or two, I think 2 articles by month, so you can take a look. Thank you.
Das ist ein anderes Teil, weil die Batterien alle sind.
So, thank you very much, Clément. Any questions about his scenario, what he did, and the magic he's shown in the live coding? Oh, yes.
Yeah, my question is, so you have shown us that you consume this open API and then save the comment in your own database. My question is, what happens if now the product gets deleted from this open API? Let's say product number 1 is non-exist anymore. Do I have now, is maybe the data automatically deleted from my database, or do I have now invalid data, or how to proceed further here?
Yeah, in a real scenario, this is a concrete problem that we can have, but most of the time, for this kind of API, you have also events. So when a product, for example, here is deleted, normally you have an event that is generated, and you consume this event, and you can delete all the information in your own database. Or the other possibility is also to, every day, call the Northwind API to check if the product is still available and delete the data if it's not available. That's my point of view. If you have more possibility in your head, we can discuss about this.
Thank you for the presentation. It was really nice. I really appreciate it. My question was regarding, so in this context, we use the Northwind API, right, in a steampunk approach with the service consumption model to write. Would it be possible with a more on-premise approach?
So yes, everything that has been shown here, it's available in S4HANA environment. The only thing that is different is on the service consumption model, which is not available in on-premise or private cloud system. But there exists some workaround. You can directly call the HTTP by method available in S4 system. And you also have a really good blog post by Andre Fischer, which explains how to create the service consumption model in the free trial BTP ABAP environment, and to download it and upload it on your S4 HANA system. So when you do this, after this, everything is possible to do on your S4 HANA system.
Someone else? No? Sir, new internet? It's internet call?
Nope.
I'm joking. Oh, and that's clear already. Thank you very
Thank
much.
you.
We're going to have a coffee break soon. I hope the coffee is also back. Coffee is gone in the morning, unfortunately. But yeah, give him a big applause. We see you again in 1 hour, right?
Yes.
Yeah, in 1 hour.
See you soon.
Schönen Tag. Ich hoffe, es gibt Kaffee, weil sonst gehe ich auch in den Zug.
Du bist doch live.
Oh.